So, greeting professor and also everyone. In my video, I'm gonna cover about the two terms to test the convergence or divergence of the series. So, the first term of the testing is ratio test. The ratio test measures the rate of growth or decline of the series by examining the ratio, which is a sub n plus 1 over a sub n. And we should take note that the ratio test is often effective when the term of the series contain factorials or expression raised to the power of n. So here we have limit and approach to the infinity of the absolute value of the ratios, which is a sub n plus 1 over a sub n equal to L. So L is the value or the answer of the result of the limit. So when L less than 1, then we can say that our series of a sub n is convergent or absolutely convergent. But if L greater than 1 or our limit is equal to infinity, and then we can say that our series is divergent. Another thing, if L equal to 1, then it is inconclusive. So now let's look at the example. So the first example is the series with sigma n over 5 raised to the power of n. As we know that for n equal to this case n over for a sub n equal to this case, it is positive whenever n greater than or equal to 1, so that we can apply the test by taking its limit is limit n approach to the infinity of a sub n plus 1 over a sub n. In this case, we don't need the absolute values because we know that our a sub n is positive. So that we use rating and we can find the answer, which is 1 over 5. 1 over 5 is smaller than 1. So by the ratio test, our series is converged. So let's look at another example, which is the series with sigma e raised to the power of minus n with n cube. So we must make sure that our a sub n, which equal to this case, must positive or greater than 0. So as we know, for n equal to 1 or greater than 1, our a sub n is greater than 0. So we can apply the ratio test by taking the limit. By taking the limit, we just substitute the value of a sub n to the limit and then calculate the limit simply, and we find the answer, which is 1 over exponent e. For exponent e, it's approximately equal to approximately 2.7. So 1 over 2.7 is smaller than 1. So we can determine the series and it is converged. So another example is the series with sigma 3 and factorial over n squared plus 1. in this case, we can find the a sub n which is greater than 0 for n greater than 1 or equal to 1. So by this case, we can apply the ratio test by taking the limit and we substitute the value of the a sub n to the limit and do the calculating, and then we step by step, and then we can find the answer that the degree of the above is greater than the degree below. So our limit is equal to infinity for the limit rule. So by the ratio test, our series is diverged. So let me talk about another term, which is root test. So for root test, we have limit n approach to infinity of the a absolute value of a sub n to the root n, which equal to L. So when we find L, if L smaller than 1, and then our series of a sub n is converged or absolutely convergent. And in contrast, if we find L greater than 1 or our limit is equal to infinity, we can say that our series is diverged. And another thing is if L equal to 1, then our series is inconclusive. For this example, we cannot find the convergence or divergence by taking the ratio test. When we take the ratio test, we got the answer of the limit is equal to 1, so that it is in conclusion. By this problem, we can take another step, which is root test. So for the root test, we apply the root test by taking the limit. So for the a sub n of the n even, we substitute it to the limit and by calculating it, it is equal to 1 over 3. And for the a sub n which is the n part here, and we substitute to the limit and we do the calculating, we can find the answer, which is 1 over 3. So both case is 1 over 3, which is both case 1 over 3, which and 1. So we can say that our series is our series is converged, or both terms converge. So an example, which is the series of sigma 4 raised to the power of n over 3n raised to the power of n. By looking at this case, we know that this case is greater than 0 for n equal to 1 or greater than 1. So we can apply the root test by taking its limit. So by taking its limit, we substitute the value of the a sub n to the limit, and then we do the calculating again, and we can find the answer, the limit of n approach to infinity of 4 over 3n. So in this case, by the limit law, and we can find the answer, which is 0. So 0 is less than 1, so we can say that our series is converge. So the last example is, this case is sigma of this term. So we let a n equal to this term, and then we find the domain of the case. And for the domain of the case, for n greater than 1 or equal to 1, a sub n is, this case a sub n is greater than 0, so we can apply the root test. So by applying the root test, it means we find its limit, and we substitute the a sub n to the limit, and we do the calculating, and then we can find the answer of the limit, which is 4/6, which equal to 2/3. 2/3 is less than 1, so we can say that our series is converge. So that's all for my presentation, for my videos, and I hope you enjoy it, and see you again next video.